everyone, it's Miss Joyce. Today we'll be using benchmark fractions to compare fractions. Let's start by comparing 1/5 and 5/6. We're going to be using benchmark fractions to compare these two fractions. We can draw visuals if we need. Remember, the benchmark fractions are 0, 1/2, and 1. So let's see which benchmark fraction 1/5 is closest to. We can draw a visual where we have 5 parts and one of them is shaded. Well, we can see that there's only one part shaded, so this is really close to having none of it shaded. So 1/5 is closest to 0. 5/6. Let's go ahead and draw a model that has 6 parts with 5 of them shaded. Oh wow, here we only have one more part that needs to be shaded to have the entire model shaded. So 5/6 is closest to 1. So if we were to compare these benchmark fractions, we can see that 1 is much bigger than the benchmark fraction 0. So since 1 is bigger, 5/6 is going to be bigger. So 1/5 is less than 5/6. We can also see that in the model here. There's a lot less shaded in our first model. So let's use the comparison sign in our sentence. 1/5 is less than 5/6. Remember, our symbol always opens up to eat the bigger fraction. Now let's try 7/8 and 3/6. 7/8 is closer to which benchmark fraction? Well, if we have our visual model, we'll have 8 parts and 7 of them shaded. Well, if we look here, we only need to shade one more part to shade the whole thing. So 7/8 is very close to 1 whole. Now we have 3/6. So in our visual model, we'll have 6 parts with 3 of them shaded. Well, half of 6 is exactly 3. So this actually represents half of the model shaded. So 3/6 is closest to the benchmark fraction 1/2. If we compare our benchmark fractions 1 and 1/2, we know that 1 is much bigger. So that means 7/8 is going to be the bigger fraction. So 7/8 is more than 3/6. In our sentence up here, we can use the symbol greater than, meaning that our symbol is opening up to eat the bigger fraction. 7/8 is greater than 3/6. Now we have 1/5 and 3/8. We're going to find which benchmark fraction 1/5 is closer to. So if we have our visual model, we have 5 parts with one of them shaded. Well, here we only have one part shaded. We can see this is really close to having none of the model shaded. This is closest to the benchmark fraction 0. With 3/8, we'll have our visual model, which will have 8 parts and 3 of them shaded. Well, if we wanted to have the model shaded, we would need 4 parts shaded. So we're only one part away from having half of this model shaded. So 3/8 is closest to the benchmark fraction 1/2. If we compare our benchmark fractions 0 and 1/2, we know 1/2 is bigger. So that means 3/8 is going to be the larger fraction. So 1/5 is less than 3/8. In our sentence up here, we'll have our symbol open up to eat 3/8 since that's the larger fraction. 1/5 is less than 3/8. Now let's compare 4/10 and 4/6. We're going to use a few less supports for this problem. With 4/10, we're going to draw a model that has 10 parts and 4 of them are shaded. Well, half of this model shaded would have 5 parts shaded since half of 10 is 5. So this is only one part away from having half this model shaded, which means that 4/10 is closest to the benchmark 1/2. It's just a little less. Now we can draw a model for 4/6. We'll have 6 parts with 4 of them shaded. Well, if we wanted half this model shaded, we would have 3 parts shaded, but we have one more part shaded over the halfway mark. This still is closer to 1/2 than it is to 1 whole since we need 2 parts shaded to get to 1 whole. So 4/6 is closer to 1/2. Well, if we look here, both of these fractions are closest to the benchmark fraction 1/2. However, 4/10 is a little less than 1/2 and 4/6 is a little bigger than 1/2. So since 4/6 is larger than 1/2, 4/6 is going to be our larger fraction. So we're going to have a symbol open up to eat 4/6, since that is our largest fraction. 4/10 is less than 4/6. Now let's try guided learning number 2. Here, we're going to compare decimals to the fractions below. So the first thing we're going to have to do is rewrite the decimal as a fraction, and then we can use the benchmark fractions 0, 1/2, and 1 to compare the fractions. So here we have 5/10 compared to 9/10. Let's first rewrite 5/10 as a fraction. Well, we are really just saying the decimal as a fraction. 5 is in the tenths place, so we can rewrite 5/10 as 5/10. Now we can go ahead and draw our visual model to represent 5/10. So here we have 10 parts, 5 of them are shaded. We can see that half of the model is shaded exactly. So 5/10 is closest to 1/2. Now let's do the same for 9/10. Well, 9/10 here we'll have a model that has 10 parts with 9 of them shaded. There's only one more part that needs to be shaded for the whole model to be shaded, so 9/10 is closer to 1/2. If we look at our benchmark fractions 1/2 and 1, we know that 1 is the larger benchmark fraction, which means that 9/10 is going to be our larger fraction. So we'll have our symbol open up to eat the larger fraction. Since 5/10 is less than 9/10, we have our symbol opening up to eat 9/10. Another thing we could have done here is when we rewrote 5/10 as a fraction, we can see that these two fractions have the same denominator, 10. We already know that 5/10 is less than 9/10, so that's another way that we can know that 9/10 is the larger fraction. Now let's try 92 hundredths compared to 45 hundredths. First, we're going to rewrite 92 hundredths as a fraction. Well, here we know that the 2 is in the hundredths place, so that means our denominator is going to be 100. And the number that we see is 92, so we can rewrite this as 92/100. We're not going to draw a visual model for this one. We were just going to use our reasoning skills to know that 92 hundredths, well, if 100/100 is 1/2, we're only 8 hundredths away from 1/2 being shaded. So 92 hundredths is closest to 1/2. Now we're going to compare this to 45 hundredths. Well, let's think. Half of 100 is 50. So if 50 hundredths is exactly 1/2, 45 hundredths is only 5 hundredths away from exactly halfway shaded. So 45 hundredths is closer to 1/2. So now we can compare our benchmark fractions. 1/2 is larger than 1/2. So that means that 92 hundredths is more than 45 hundredths. So we'll have our symbol open up to eat 92 hundredths. Last one, we have 52 hundredths compared to 8 hundredths. First, we'll rewrite 8 hundredths as a fraction. So we can see that 8 is in the hundredths place, so we know the denominator is 100, and the digits we see are 8. So this is going to be written as 8/100. So now let's figure out which benchmark fraction 52 hundredths is closest to. Well, we said half of 100 is 50. So this is only 2 hundredths more than halfway. It's only 2 hundredths more than 50 hundredths. So this means that 52 hundredths is closest to 1/2. Let's do the same for 8 hundredths. Well, 8 hundredths, that's only 8 hundredths more than 0. So that means that 8 hundredths is closest to 0. So 1/2 is our first benchmark fraction, and 0 is our second. Well, we know that 1/2 is larger than 0, so that means that 52 hundredths is more than 8 hundredths. So in our sentence above, we can have our symbol open up to eat the bigger fraction, which is 52 hundredths.